Hello and welcome to another AP Daily video. Today we're going to continue to talk about algorithmic efficiency. In this video, we will identify solutions where a heuristic solution may be more appropriate. This is Mrs. Julie Alano again. I teach at Hamilton Southeastern High School in Fishers, Indiana. So what will we learn? Today we're going to focus on identifying solutions where a heuristic solution may be more appropriate. Still a similar learning objective, but a different part of it. So we're still going to be taking a look at problems, and today specifically we'll be looking at decision and optimization problems. We're still going to be talking a little bit about efficiency and the fact that if an algorithm isn't efficient, then we may need to use a heuristic. So here you see a heuristic is an approach to a problem that produces a solution that is not guaranteed to be optimal. So we're going to talk about that as we look at some examples. We have a problem here called the traveling salesperson problem. The traveling salesperson problem is, given a set of cities and a distance between every pair of cities, the problem is to find the shortest possible route that visits every city exactly once and returns to the starting point. So let's take a look at an example. Here we have some cities in the Midwest, because that's where I'm from. And you can see I've calculated the distances between those cities. So we have the paths labeled with their distances between each city. So since I'm near Indianapolis, we're going to use that as our starting and ending point. So with this problem, we're going to search for a solution. What is the shortest path? So the first problem here, we're going to take a look at, and I have determined a path. So the first path is Indy to Detroit, then Detroit to Chicago, Chicago to Louisville, Louisville to Cincinnati, Cincinnati to Columbus, and then back to Indianapolis for a total of 1,245 miles. So that is one solution to this problem. And there I just picked a path, tried to see which path might be short. So in this solution, we're going to try out another one. So this time we're going to start by going from Indy to Chicago, then Chicago to Detroit, Detroit to Columbus, Columbus to Cincinnati, Cincinnati to Louisville, and Louisville to Indianapolis. In this route, it turns out that it only took 987 miles. Well, that one's better, but how do I know it's the best route or the shortest? There's a lot of options here. I could keep trying. And what if there were more cities? What if there were 100 plus cities? And how long would it take to try all those routes to make sure I got the shortest route? Would this algorithm run in a reasonable amount of time to just keep trying cities and looking for the shortest route? Probably not going to run in a reasonable amount of time. Is there a better way than just trying all the routes? In this optimization problem, a heuristic may be used. So a heuristic is an approach to a problem that is not guaranteed to be optimal every time, but can be used since finding the optimal solution would take an unreasonable amount of time. So as I said, with 100 cities, we wouldn't be able to try all the options. But if we were able to use a heuristic that would give us likely a good solution every time, but it doesn't take as long, that's a better approach in this case. So for the traveling salesperson problem, a heuristic that could be used would be nearest neighbor. So let's try that here. So if I start in Indianapolis, we want to go to the nearest neighbor, which would be Cincinnati, 112. Then from there, the nearest neighbor is Louisville. And from there, we'd have to go to Chicago. Chicago to Detroit, and then Detroit to Columbus, and now back to Indianapolis. And so by using the nearest neighbor approach, we came up with a total of 1,166 miles. Not the best, but it's definitely not the worst. And so that's where heuristic comes up with an optimal solution, but maybe not the best. But in searching for the shortest route, we would run in an unreasonable amount of time and it wouldn't be practical. So let's take a look at some practice questions. In which situation would a heuristic be useful in solving the problem? A, searching a list of prices for the smallest value. B, creating the master schedule for a high school. C, calculating the GPA for all students in a school. Or D, generating passwords that meet certain criteria. So you want to think about, is there a set solution to some of these problems? Or would there be possibly more than one solution and it would be difficult to determine the best solution every time? So searching the list of prices for the smallest value, we could search and know that we found the smallest value. So probably don't need a heuristic there. Creating the master schedule for a high school will depend on the size of your high school, but there are a lot of things that go into that. Making sure that you are able to get all the classes you want to take is not easy, especially when there's only one class offered at one time of the day, trying to get all the students into that class. You're probably just going to have to go with an optimal solution there. So since I determined that's probably the case, the others seem to be general calculations or trying to come up with certain things. B would be the answer for the one where we would use a heuristic to solve the problem. So what should we take away? Again, identifying situation where a heuristic solution may be more appropriate. So as we just did on that last example. So remember that we were talking about decision problems and optimization problems, which you can find defined here. And based on the efficiency and algorithm, we determined that a heuristic approach is probably better in some situations. Thank you. Have a great day.